dependency inversion principle, the last in the solid code principles. Okay, so the dependency inversion principle says that a high-level module should not depend on a low-level module. Both should depend on abstractions. And abstractions should not depend on details. Details should depend on abstractions. All right, so how do we feel about string, vector, or anything else in the STL?
Big fan.
Big fan, okay. But now that we've just very quickly learned what the dependency inversion principle is, how do we feel about using things like string, vector, and other things?
I'm conflicted.
You're conflicted, okay.
Apparently you shouldn't depend on them because they're low level
So what are you going to use instead?
abstractions.
So you're going to use an abstract string class? An abstract vector class?
Don't want to.
Right. We don't want to, so we can't. Like, it's not realistic to say that we're not going to use string or vector or any other container type that is very concrete. And just spending our time depending on interfaces that are around them is kind of silly because they're just developed in the system, right?
It's essentially pod stuff, right, to us.
Yeah, they're fundamental types,
Yeah,
right?
right.
It's worth noting, they aren't going to change.
It is worth noting. So the very important point why it's okay for us to be using things like that is because they are very non-volatile. They don't change very often. At most, with every version of the compiler you move to, but at least while you're sitting there with the current version of the compiler, you know nothing's going to change between them. So you don't have to worry in the middle of developing your application that string is suddenly going to stop working the way it used to yesterday because it's still the same string class. So
Also apply to things like MFC or .NET or.
yeah, any fundamental library type or something that's third party that you know isn't going to be changing frequently underneath you, like maybe from release to release of your application or something. Yeah, just any library like that, Boost, Qt, whatever that we use, Stingray, MFC, yada yada yada. As long as you know that it's not something you have to be getting updates every like day or week or month.
You control.
Yeah, you say, okay, well, this release we're using this version of X library or whatever, then you're able to control the volatility of that dependency. So,
Yeah, and you also feel pretty confident about throwing the precompiled headers. Because,
yeah, they're not going to change.
right, if they did, oops, you'd be rebuilding everything. That would be ugly.
Yeah, that would be ugly. So these library facilities are very concrete, but these libraries like the STL are also non-volatile, so it's not, like, this is basically a concession to, let's not get too carried away with this dependency inversion principle idea that if something is non-volatile enough, it's not bad to be depending on it concretely.
So it's just, I mean, the volatility, I just, when you say higher level should not depend on lower level, down to this level, it's within your application and the things you're creating, things you have control over that you're modifying. Whereas this SDL and other libraries are the basis for what you're working with in your environment.
Right.
You know, but if you make some low level things and then make some higher level things on that, your higher level things shouldn't depend on your low level thing. It's okay to go ahead and be working with these.
Right. So yeah, that's kind of the point of this whole thing is that to think of your application code differently than you do some sort of like library thing that's more fundamental to how you build up the blocks versus the blocks themselves now. So the dependency inversion principle applies more to the application code than it does for library dependencies or whatever. Not to say that it's completely gone with library dependencies. If the library does offer you an abstraction, then it's good to use it. But things, again, like string or vector or whatever, there's no reasonable way to avoid them. So application interfaces, which are something that you would actually be building in your application, those are different. And we've kind of touched on that now. So it's kind of implied in the name, but how can you reduce the volatility of the code in your application?
Using interfaces.
Hey. Yeah, so concrete implementations don't usually change the interface. So just a small little change into the implementation of some part of your application isn't going to necessarily cause some big change to the interface. So that interface, therefore, is less volatile because it doesn't change with all changes to implementations. Implementations always change when the implementation changes. tautological, but the interface doesn't change necessarily when an implementation changes. So we've identified a piece that is less volatile than the other.
Unless you're the workbench.
Right, unless you're, yeah, so that is the whole like stable interfaces idea, that you should try to define an interface that can be stable, unlike what the workbench seems to be doing.
And even in cases where the interface does change, it's possible to remain compatible with old uses.
Yeah, that's true too. And you can even get as far as like versioning interfaces, like with what you would do with COM, where you have a V1 and a V2 or whatever, if you needed to really try to guarantee that non-volatility. But usually within your application, it's not worth worrying about. Yeah, so interfaces based on above are less volatile than concrete implementations. So based on just these simple ideas, we can define some coding practices, which are from, of course, Uncle Bob. So don't refer to volatile concrete classes. So if you're using a concrete type in your application that's changing every fourth bug report or requirement change, always changes this class, don't refer to it concretely. Try to either define an interface or you find an interface for it that you can take a dependency on over the volatile concrete. Don't derive from volatile concrete classes. So anytime you derive from a class, your implementation is now defined in terms of that other class. So anytime it changes, you immediately have to change. Usually at minimum by a rebuild, which then percolates out to anyone who's using your class. So we can kind of hedge that off by implementing an interface rather than deriving from a concrete class. So that way changes to a concrete implementation don't affect any subclasses.
Right, and if you did that, it would make your class volatile.
Exactly, yeah, so you also inherit that volatility, yep. Yeah, so don't override concrete functions. There's source code dependencies that go on there because you are now inheriting all of the things that are part of the rest of the class. Like code coming in has a certain dependency on that might not be as well prescribed as an actual interface. This is less of a thing for C++. In Java, basically every function is a virtual function. You don't have any control over virtuality in Java. So I think this rule probably applies more to Java there. If you're marking something consciously as virtual in C# or C++, chances are you're not going to have as big of a problem there. But something still to keep in mind, I guess. And finally, just never mention the name of anything concrete and volatile, which really, I'm sorry?
Voldemort.
What? I'm not a Harry Potter person, I don't know.
Okay.
Okay.
They don't mention the name.
Okay, got it.
Never mention the name.
Yes, never mention the name. And that's just a way of saying don't take a source code dependency on that thing. So if you never mention the name in your code, then your code does not depend on it. Okay, so one big thing is that creating an object requires that you take a dependency on that object. So we have a class that does something, and it has some other functions just to kind of demonstrate that it's doing things. And then finally we get to a part where we have to, oh, well, this other class is responsible for this last part of it. So we instantiate that some other thing class, and now we call the doIt function. I put that in there for you, Mr. Shumway. That is able to finally finish it off. Obviously, because we had to construct the thing, we have a dependency on it. And now anytime some other thing changes, we have to rebuild my class. So we've inherited the volatility of that type.
Doesn't that make your talk dependent on my being here?
Only in that little mention. I was looking for a function. I remembered you said, well, I think doit's a perfectly good name. It does it. So I was like, okay, we'll use that. I was hoping you'd be here.
Oh, no, you were depending on.
That's fair. Okay, now, actually, any thing to say about this slide? I mean, it's nothing spectacular. It's pretty typical though. Like we now have to do this last part, so we go instantiate the guy that does it.
So instead, we would instantiate something else that we're already using and use an interface to get to what that is.
Yeah, the problem though is that creating anything or instantiating anything takes a dependency on it, right? So really the rule is that you can't instantiate to be able to follow the dependency inversion principle. In the Java world, and it also applies fairly closely to C# would be that you shouldn't have new in your code. We can get away with that in C++ in a terrible way by not having new because you can put things on the stack. But the idea behind not having new in your code for Java or C# is that you have to instantiate a type with the new keyword. And so it's really saying don't instantiate types inside of your implementations for those other languages. So here we're violating the no news rule, but using a different syntax. So we can't, I'm honing in on that whole instantiate something else. Because if you instantiate that something else, then we're still taking a direct dependency on that something else.
But if it's something else, well, I was thinking something else at a higher level that you may already be using, or somehow, it's a compromise, but how do you get to an interface to get to that thing to do what you want to do?
That is an excellent question, Rob. Okay, yeah, so the problem would be that if you try to instantiate a type that can get you to that other thing, then it is still a concrete implementation, even if you consider it a higher or lower level. So what we really want to do, I'm sorry?
It's less of a problem.
It's less of a problem, but it's a smaller version of the original problem. So we want to really have someone basically hand us that interface rather than us being worried about it. Like my class shouldn't be worried about the instantiation
Take it as a
of that
problem.
type. Right, so we'll see it. But now that we've looked at that for a while, notice that the direction of the dependencies matches the flow of control. So if we go back now, the flow of control is kind of going along, doing an implementation, and suddenly we dive down into the control structure, and we now have this dependency. So my class flows down to the dependency that it needs. I don't know if I said that very well, but yeah, this is why I wanted to, hopefully this works. I want to exit first. I want to, let me pull the whiteboard. No. Okay, whiteboard. Yeah. Okay, so pretty typical. All right, so a pretty typical thing, and I covered this like week 1 when we were talking about the extension framework, was how you have a typical like component composition where things are broken down from like higher level components to like middle components to, I'll move out of your way, right? To low level components. So you can see in the code that that's sort of where we're driving down to, that my class in this example would be a high-level component that is now depending on, we'll call some other thing a low-level component. We'll just kind of stick straight to it. But the idea is that the flow of control is matching the level of composition in the code. So we're using these smaller pieces to build up the higher-level policy of the application. So the flow of control kind of goes downward like that. Right? But because of, if you continue to implement things in that fashion, the dependency structure also flows in the same direction. Right? So this should look familiar.
Right, so meaning any change in a low-level thing implies that the middle and then high-level, all that to the leads.
Yeah, so everything is kind of like sitting on top of each other. So the high-level dependency, or the high-level policies depend inevitably through these dependencies on the low-level components, right? And that's what we're seeing here. So that's kind of the codified version of that diagram that I had drawn before and now redrew. So what we want instead, where the blue lines are dependencies, we want to be able to say, okay, well, the flow of control has to happen this way because that's just the reality, like that's how this application works. But we don't want the dependencies to necessarily go in that direction, so what we really want to see is the dependencies flowing in the other direction, against the flow of control.
won't the higher level things depend on the lower level things?
Well, the way I drew it's not best, but the idea is I was trying to emphasize that this is the flow of control, and we actually want to go against the flow of control. This would imply then that the lower level things should depend on the higher level things, which is a little strange, but we'll go over that. Yeah, so I regret that diagram now, but hey, you get the idea. The gist of this is the flow of control, and we want to swim upstream against that flow of control.
Helps illustrate the inversion that you're talking about.
Yeah, I just don't know why I didn't do it right, but whatever. Just take that idea and we'll continue. Can I save that? Just real quick. I'm already saving it. Okay. So we want to not go with the flow of control is the gist, right? So how can we, why are my animations not working? How can we avoid the concrete dependency?
Factory.
Using factories. Okay, so the idea is that kind of along the lines of what you said is that there's some other type that knows how to create that thing that we don't want to take a direct dependency on, right? But in this case, we have instead, our application would be like the my class, and we have this concrete implementation right now of the some other thing type, and we want to be able to control it, use that thing without taking a direct dependency on it. So one first thing is that you define an interface for that concrete type that you don't want to take the dependency on, but now you have to somehow get it, right? So we have a factory type which knows how to make that concrete implementation.
Okay.
So the factory implementation makes, he's calling it a service as a screenshot from a different thing, but you're making the service or that concrete type, and then that happens to implement an interface, and the application code, the my class, would take a dependency on an interface of that factory. So that's what the I means.
So it can tell the service factory, please make me some other thing.
Right, and so now all the dependencies are on interfaces now, because you're just taking the service factory interface and this service interface, and this red curve represents a architectural boundary. So some other component basically is providing the concrete implementations of those interfaces. Does that make sense? Okay. Cool. All right, so what does that look like? We have some other thing we've now made an interface. So it just has a do it function that's pure virtual. And then we have the thing factory, which also has a pure virtual function that just makes something or some other thing and returns a unique footer, which is just, to manage the lifetime of that object on the heap, because to be able to use like the runtime polymorphism, the object has to live on the heap. So now this red line suggests the architectural boundary, so this would be one component, and then where this is an abstract component just describing what the types look like, and then now we have the concrete component where we have the implementation of that some other things do it function, and he just implements the interface and overrides the do it function, and then you have the factory, which just knows how to call make unique on that type. So this is the line now that takes the hard dependency on that concrete implementation, but it's isolated from the abstract component.
So you never get away from some of the implications of, because you have to, somebody has to depend on something somewhere,
Right.
but you can limit the scope and therefore limit the damage
Yeah.
when the changes happen.
Yeah, so the concrete factory has no choice but to depend on that actual type. Yeah. Cool. Questions? All right, so this is what it would look like back in my class. So we add a new data member that just has the thing factory, and we're back into the these two function calls, and now we need a thing, so we just call to the factory and ask it to make the thing, and now we call the do it function.
So now your my class is, when it instantiates, it's instantiating a thing factory.
No, because it's accepting the thing. I'm sorry, I should have then said that. So we take the thing factory and its constructor and then stuff it into the data member, and now we're free to use it later. So there's calling code now on the my class that would have to have a thing factory. Sort of turtles all the way down though, in that anyone who makes a my class shouldn't have to know about the concrete, because you need a concrete factory now still, which is again a smaller version of the problem. So whoever creates a my class now needs a thing factory, which they don't want to have to know about that concrete thing factory, so then they would have something that then can send in a thing factory, and then you have dependency. This is called dependency injection, to give it a term. And to do it correctly, you have to inject dependencies all the way through to the main. So you have your application boundary and the main boundary, where the main starts everything up and then satisfies all of the dependencies for the application. So once main basically injects everything, the application has all the dependencies it needs.
But that makes it sound to me like, all right, so if you want to write a program that uses this stuff, your main program it becomes very complicated by having to create all these things first to provide them for my class or whatever.
I would say that not complicated, it just, there's a lot there, because you'll have to, like you said, satisfy the dependencies. The complication is really in the factors. Anywhere that the creation of the object, or anywhere where there is a creation of an object, should be put into the factory such that the main doesn't actually have to know how to create things. It just needs to know the types at the very root of everything.
But if you're making my class and then you want to give that to somebody else to use your class, you're going to have to say, well, you're going to have to make a thing factory too, and then blah, 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 and it could get complicated for those developers.
Well, but you would also have a my class factory, okay?
Okay.
And then someone might need a factory to make the my class factory. Like, that's why I said it's turtles all the way down, but yeah, so.
Yeah, that's what's occurring to me. I mean, ultimately, you're still dependent upon the actual thing class. You just put some indirection on it. But
Right. Well, no, you're not dependent on the thing class. I kind of swapped the names out here, so it was sort of a switcheroo, I guess you would call it, but some other thing is now a pure virtual interface.
okay.
So the impl is in a different component entirely, so you're only dependent on the abstract interface now.
Right.
And so you do have a dependency on this make function will return the interface, so you have that dependency, but you're no longer dependent on the implementation of the class. And you're not even dependent on the factory's implementation because you're using the interface for it.
I guess I'm just thinking, when I say complicated, that may not be the right term. It's just, it might be, if somebody's trying to use a my class thing, another developer, it might be harder for them to understand all of the things, either more to, read me, here's how you use it, or automation that you have to, I don't know. It just seems like it would, take a little bit of work on the developer's part to understand what it is to do this right.
Yeah, and that, I started this before most of you were here, saying that I didn't give myself enough time to prepare for this. I thought it would be easier than I thought, or that it was. But there was an article from, well, stepping back a bit. So Google has these roles called software engineer in test. And so they sit on their software engineering teams, and they are testers, but they write code. And their entire job is to make their code testable. So they work with the engineers day to day, coming up with ways to, okay, well, that was cool, but we need to make that testable so that way we can, get automated tests and blah, blah, blah running to make sure our code quality is good. And one of them wrote a really good article about this sort of thing and your concerns, or talked specifically to your concerns. And the issue that they addressed was what you're saying, that, well, okay, but now my class used to be easy, you just instantiate it and call the function, but now suddenly you're telling me I need a factory, and and that's why I was saying the turtles all the way down kind of thing, that if you do start to do the turtles all the way down, at the end of the day, what you really need is just the surface boundaries of dependencies to be injected. And then from there, everything sort of percolates. So that's where, again, the main would be to provide those surface level dependencies. You inject all of those, and then from there, all the factories sort of just start to fall into place, like things just kind of lock
Yeah, I mean,
in.
once you get to that point where,
Yeah.
because you have to, somebody has to know all the surface level things you have to write
Right.
first for that to happen.
Yep. Yeah, and this gets into why one